Hello and welcome to what will hopefully be the final video. In this one I will be talking about keyboard input, collision system, game objects, and the sprites. Let's begin. So here we have an input, an inputable. So these ones are a little bit different than the alarmables, where those had a set amount of their data structures. The inputable can have theoretically as many keys as there are on your keyboard. So, it's a bit big. Got a delete map function though. So it deletes its own maps. Takes care of itself. Cleans up nicely. Most of the stuff is fairly similar, except there's an added step. You see, for every registration, it's not registering strictly to what would be the equivalent of the inputable event manager. Rather, it's creating a single instance of a single key event manager, which cares simply for a single given key, that being whatever key you pass into it upon registration. And you can register multiple keys, obviously. As I said, you can have as many as there are keys on a keyboard. So, the inputable, so it creates a single key event manager. This one listens for whether or not the current key, the key that it cares about, has been pressed. Now the thing about this that's neat is that an inputable, you can have multiple inputables all accessing the same key but only one single key event manager. And that's the beauty of this system, is that you could have theoretically infinite inputables all talking to the same key with one event manager. They would simply ping all of those things because they've all been marked as caring about this particular key. The overload, that's another thing that I forgot to mention in the previous things. So drawable and updatable, they both have a virtual function that you need to overwrite. In drawable's case, it's the two draw functions. In updatable's case, it's update. And in alarmable, it is 3 alarms. And in the case of inputable, it is these two, key pressed and key released. Now another nice thing is that it doesn't matter how many registered keys you have, you only need to overload key pressed and key released once. Or not overload, you only need to replace, you need to make your own key pressed and key released once. It'll cover all the keys. That's really sweet. That's swell. It's nice. Anyways, let's look at this. So, this is the state manager, which keeps track of whether or not the key has been pressed or released, and whether or not to update itself accordingly. So if you press it down once and hold it down, it'll say key pressed, and just that's it. It'll stay there. It won't call key pressed again every frame. It'll wait for you to release the key, and then it'll call its key released, and then it knows that it can run key pressed again. Registration is just inserting into the map. It is not an ordered map like the last one. Oh, no, wait. Oh. Yes, I am a dumb. This is a list, not a, this contains 2 lists. Actually, key pressed and key released maps. That's for whether or not you care about key presses or key releases, which you can specify. Yay! So anyways, so like I said, these things will run through and let's say, for example, this event manager has a thing of E, so it cares about when E is pressed. So, when keyboard event manager, which is contains just a map of single event managers and runs through them, when it hits E, it'll go here, and this thing will ask, okay, everyone who cares about the button E, something has happened. and then it'll tell it the appropriate thing that has happened. And that is all. And every key will do that. Now the keyboard event manager, seen here, contains a map of Azul keys and the event manager pointer that it points to. When it doesn't have the relevant key manager, it'll create it. That's kind of it. At the end of its life cycle, it deletes the list, kills its own map. Same as everything else. Anyways, so that is all for inputables, and just a moment, I'm going to pause this recording and get the next part set up. Alright, I'm back, and welcome to Collision. It's fun. Command, so all the same stuff as before, registration, things, but it has a few extra bits tacked on, specifically collision, volume, B-sphere, and a model. Let's just jump right into that. So, collision V-sphere is a bounding sphere which contains a center and a radius. It can check itself to make sure that it is touching something or not, specifically another bounding sphere. Other things will be added in the future. Simple math to set up the bounding sphere. And then just a few getters, setters. That's really it. And then it can check itself. It can call a function which is called elsewhere. Right. Sorry, lost my train of thought. Anyways, normal stuff. It can register itself, deregister itself. But unlike most things, this is type dependent. It's using templates. So, every time a collidable is every time a collidable of a given type is created, so let's say my frigate, for example, every time you make your first frigate, it will create a collidable group for that frigate. Why did I even open that? It's all templates. A collidable group is a singleton, right there. Well, that's where it's being set to null. And it's also not public. This is here. This is in between. That's not public. But, see, it's up there. It's private. Anyways, so this thing will go around. This will be created, and then any future ones that are any future frigates that I might want to make, just get added to this collidable group. And then it basically, it also has the deletion, it has the registration. It's kind of like a variant, a more extreme variant of the inputables from earlier. Anyways, Collidable Manager. So the Collidable Manager handles surprisingly little. It's really just for containing the collision test commands and then running the collision test commands. So that's the thing. When you in order to have collisions, you need to use collision test commands. To do that, you do set collision pair, give it 2 templated types, and then it will create, or you can do set collision single, set collision collidable group, collision test command, collidable self. So the collidable pairs, though, will create this. And it'll run this every time, which is it'll grab the 2 relevant collectible groups, and then it will run this logic through them. And actually, hold on. Sorry about that. But yeah, so collidable test. Oh, yeah, something else to note, collidable test self will not check itself. It won't compare itself to itself, because it just looks ahead. Very convenient. Anyways, so this will grab the bounding spheres from the collidable objects and then test whether or not they intersect. If they do, it'll say, great, run their collisions, run their respective collision functions, which collision is the special overloaded function. Now, collisions are not overloaded, virtual function. Now, the difference about collision's virtual function is that you need it for every different type of collision. So, let's take a look back in my scene demo. So, Bullet has 3 things that it collides with: a cottage, a frigate, and enemy. That means that Bullet has 3 different collisions: a collision for Bullet, or a collision for cottage, a collision for a frigate, and a collision for enemy. Right, back to this. So yeah, that's what the collidable pair does. Other than that, collidable manager. I honestly think that that's about it. So at the end of the level, when the scene is done, the collidable manager will delete all of its collidable test pairs, and the collidable groups are told to empty themselves of anything relevant, because they're singletons. Alright, so that is all for... And that is all for collision at the moment. Be right back with the next part, game object. Alright, so game objects are relatively simple for me. I went with the variant of game object where all things are derived from it instead of it from everything. This was done so that you can more easily pick and choose the stuff that you want your specific game object to have. Like, for instance, my frigate has everything. My cottage doesn't need everything. My enemy doesn't need everything. My enemy doesn't need to have inputables. What does it need to input? My cottage doesn't need a timer. Why would it need to time anything? It is just sitting there. So yeah, that's all for that. But it does have these 2 very important things: scene entry and scene exit. Scene entry and scene exit are the virtual functions that it calls. Right here, actually. So what this does, what these are used for, is for any registration and deregistrations, basically. So you don't want to put those in your constructors and destructors necessarily. What you would rather do instead is simply have them in your scene entry and scene exit, so that way you can do things. It's for making sure that you can have an object appear and disappear in the same scene, potentially repeatedly, like my bullets do. So that's really it for this game object. It is also called through its command pattern, as it should be. Now then, on to the final part, sprites. Sprites are a little different in that they are not an actual game object. Rather, they are a regular object that you treat almost like a model. So in order to create one, you give it an image and its size. And that can be seen right here, where it creates its center, creates all of these different setups for itself. It keeps track of most things about itself. It has a matrix that acts as its center, a sprite model, sprite image, sprite shader, and a sprite object. Sprite graphics object. And it auto-generates all of that stuff for you. All you have to give it is the image and where you want the image, essentially. Now it also has a series of setters and getters. So the sets include 2 for the setting of the center, 1 for the setting of the world for if you want to do all of your math on your own, 2 set positions, a set rotation, and 2 set scales. The second set scale here is for pixels, so you give that one the pixel size of the object that you want. So let's say you want it to ultimately be 100 pixels. This thing, 100 pixels by 100 pixels. This thing will squash or stretch that thing to be 100 pixels by 100 pixels. The others work about as you would expect them to. Set position moves its position to whatever you set it to be. Set rotation will alter its rotation. Now, there is one a little difference for this thing, for the sprite. And that is the draw. Like I said before, this draw specifically to a 2D camera. So in the camera manager, there is always a 2D camera set aside specifically for sprite drawing, and it's called the sprite camera. And so this render will just always render itself to the object, to the camera. Now, in order to demonstrate a bunch of these things in action, I'm going to real quick just go through the frigate. So the frigate has 3 sprites acting as its health. These sprites are in an array, and as you can see, so to create a new sprite, you just tell the image manager to give it a new image, and this is this is not the location, but the size that I wanted my sprite to be at. And then you can set its I set its position down here so that it's 1, 2, 3. But yeah, so yes, let's just look through this. So here's the key pressed and key releases, scene entry, scene exit. That's for getting pushed backwards when you're colliding with an object. Update. Collision with a cottage. And again, a collision with bullets. The alarms. This alarm sets itself after it goes off. It's draw, and it's draw 2D. Alright. Well, now time for the final piece, which would be a look at the Circle API. So this is just quick stuff. Gives you a very basic overview how to, generate your how to get the basic stuff working and get your initial scene up and running. Similar to the stuff you saw before. Alright, this video went on for way longer than I thought it would. I apologize for that. I guess this is the end of my video. For that, I'm just going to, real quick, that's the CPP. That's the wrong thing. Real quick, go through the all of the documentation that I kind of just skipped. So sorry about that. I was kind of saving it towards the end. because documentation is a big old thing. So as you can see, I have documentation on all of my classes, with the majority of them do, in fact, have some tidbits just describing what do they do, why do they do it. All of the most important stuff, things like collidables, all of the UBLs have their own things. The game objects describe themselves very well. Updatable. Yes. So that's all I have for you, I think. That's my video. Have a good day.